ठीक है, let's start with this paper. इसको थोड़ा reverse direction में, ठीक है? And just a second, let me open the revision board as well for organic, ठीक है? So ठीक है, this is available. So I'm just going to start with past paper questions, starting with the first one, which is he's asking an organic compound T does not fizz when aqueous sodium carbonate is added to it. So no reactions with a carbonate, right? So so Na2CO3. Remember this, carbonates, they react with acids, right? So it does not fizz, does not produce carbon dioxide gas. That indicates that it's not an acid. So option number 3 is out of the question. Okay, that's gone. It's not an acid. And the other one is that it contains 27.6% by mass of oxygen. What could be the identity of? So you have two options. One of them is propanol. That is double bond ONH. And this is 2 hydrogens, this is 3 hydrogens. So figure out karo कि क्या होगा इसका 16 divide by the total, which is what? 3 carbons, that's 36 plus 1 oxygen, that's 16 plus there are 6 hydrogens, I think. So that's 6. So or into 100 karo. So what would you get for that? That would be what? 16 and divided by brackets 36, 3 carbons plus 16 plus 6. Then you get 13.55%. Propanol, right?
You added 66 instead of 6.
क्या चीज?
You added 66 instead of 6.
Oh, अच्छा ठीक है. इसको फिर देख लो कि अच्छा वो सही हो गया खत्म. What's 36 plus 16? Mentally कर लेते हैं. That's 52 plus 6. That's I think 58. So 16 divided by 58 gives you, we are at 27.6%. So the first one is correct. What about ethyl butanoate? We have to figure that one out. That's an ester. Ethyl, that's 2 carbon atoms on the single O side, and that's ethyl, and butanoate is 4 carbon atoms on this side. So you have to figure this one out. So CH2, CH2, and this would be CH3. Anyways, 2 oxygens, so that's 32. Divided by the whole thing, which is how many carbons? That's 6 carbons in total. So that's 12 into 6, that's I think 72. Plus there are 2 oxygens, so that's 32. Plus how many hydrogens? You've got 3, 3, 6. And 6 and the 6 in the middle, that's 12. So kya ban gaya? That's 44, 72 plus 44. So that's going to be 32 divided by 72 plus 44. And that ठीक है, ये भी सही है, 27 points. So it's going to be 1 and 2. ठीक है, just remember कि it's not fizzing. That means it's not a carboxylic acid. ठीक है, clear है? So then the next one is 2 carbonyl compounds have the molecular formula C3H6O. Which reagents give different observations with these 2 compounds? Now it's 2 carbonyl compounds, aldehydes and ketones. So there can be only 2 because it could either be an aldehyde or it's going to be a ketone. Okay, so you're going to have these 2 options, or these are the rest are all hydrogen atoms. So this question you've got इसके साथ ये बाकी सारे H होंगे. So he's saying which reagents give different observations with these two compounds. So the first one is potassium magnate 7. Remember, ketones don't get oxidized. TK, I have the chart over here. TK, if you look at the chart, you're going to notice that alcohols get oxidized by KMNO4 to form aldehydes, like primary alcohols, this one, and primary alcohols, and you've got secondary alcohols that will get oxidized to ketones. Ketones don't have further oxidation. Further oxidation of aldehydes happens by toluenes or phelling or K2Cr2O7, and they turn into carboxylic acids. Ketones are not going to get oxidized because they don't have any oxidation whatsoever. So so the first option, option number 1, is K2 carbonyl compounds are the molecular formula. So the first one is wrong. But that is correct. Actually, you get different observations. You're going to get different observations. This will get oxidized. This will not get oxidized. Felling, that will also get give you different observations. Why? Because one of them will get oxidized. The other one is not going to get oxidized. Like, agar yahan pe dekho na, aldehydes, if I make this bigger, aldehydes turn into carboxylic acid by oxidation using felling. Ketones don't get oxidized. They don't have any oxidation whatsoever. So again, there's going to be different observation. Felling ke saath, the observation is going to be you're going to get a red precipitate with a felling. Achha, so usme it's going to be that will give you a different observation. And then you've got alkaline aqueous iodine. Ye kya karta hai? That's the Ido Form test. The Ido Form test is given somewhere over here. This is the Ido Form test. And the Ido Form test is for specific functional groups. And those functional groups are CH3 next to serial bond O or CH3 next to CHOH. Agar exactly ye structure hai, then the Ido Form test will be positive. This carbon will turn into a carboxylic acid or a salt of the carboxylic acid because the conditions are alkaline. And the CH3 will break off and turn into CHI3. So it has to be a CH3 right next to a serial bond O. So if you look at this molecule over here, this molecule has a CH3. I mean, the ketone has a CH3 right next to a serial bond O. So it will give a positive test with iodoform. This one will not because it has a CH3, but it's not next to a serial bond O. So this one will give you a positive test with iodoform, and this one will not. So again, it's going to give you different observations as well. ठीक है, clear? Okay, both of them are going to give you different observations. Ido Form test, remember this, it only happens for this one. It only happens for a methyl that's right next to a serial bond O or a methyl that's right next to a CHOH. Next one is previous clear. Alicia, is this clear? Rubab?
Yes.
Okay.
Yes, sir.
So the next one is, I'm assuming you have your exams in 18 days, right? 10 days actually.
Yes.
Achha, so jinka nahi hai na, you can just बाद में हम discuss कर लेंगे, ठीक है? Just a second. In excess of P reacts with Q in the presence of concentrated sulfuric acid to form R, and effervescence is seen when a piece of sodium is added to pure R. The structure of P is shown. Which organic compound could be Q? First thing, this is what an ester. These are the conditions for esterification. Okay, this is a P. It's got a carboxylic acid functional group. Concentrated sulfuric acid is always used to make esters. So this has a carboxylic acid group and it also has an alcohol. Now it can make esters with both. Esters are made when an alcohol reacts with a carboxylic acid. तो carboxylic acid OH is lost और इसका जो है ना वो H चला जाता है, ठीक है? And they end up combining together to form an ester link. Now this molecule has both functional groups. तो पहले तो ester वाला part, will it make an ester? It's going to make an ester with carboxylic acid. The alcohol part will go and react with the carboxylic acid part, and they would form an ester. It will also make an ester with an alcohol as well. The alcohol will go and react with the carboxylic acid and an ester will be made. The only thing it's not going to make an ester with is a ketone. This one is a ketone, so it's not going to make an ester with that. Clear hai baat? ठीक है, is this clear?
Yes, sir.
अच्छा, मैं दोनों molecules draw कर लेता हूँ. What's going to happen is, now the second part is, R is going to be produced. Effervescence is seen when a piece of sodium is added to R. So let's talk about the first one, carboxylic acid. Remember, the carboxylic acid would form an ester with the alcohol. So I'm going to do that. I'm going to take this first one and I'm going to react it. So it's 2 carbon atoms and then it's a carboxylic acid. It's a double bond O and OH. So the OH will be lost and the H will be lost, and the 2 compounds will join up over here. They're going to link up. They're going to link up and they would end up forming an ester. बीच में से it's going to be a condensation reaction and the water molecule will be removed. So that's an ester. Will it react with, so this is R. This is the compound R. इसके साथ ये मिलके it's going to form, P and Q will react to form R. So that's your R. That's option number 1. So effervescence is seen when sodium is added. It will be seen because sodium reacts with acids. This is a carboxylic acid that's still intact, and metal plus acid produces H2 gas. So there's going to be a reaction and effervescence will be seen, right? So iska matlab hai first one is correct. When a piece of sodium is added, compound R will give you a reaction with sodium metal. Second one kar lete hain, if option number 2 is correct, what's going to happen? What would be compound R? Ye alcohol aayega and it will react with the carboxylic acid. So you have an alcohol, a 2 carbon atom alcohol, and it will react with the carboxylic acid. The OH will be lost and the H will be lost over here, and the 2 will link up. And they would end up forming an ester link over there. So this is going to form an ester link at this point. So this is compound R now, okay? Will it form is tarah ka ester link ban jayega? So will it do the second part? Effervescence is seen when a sodium is added. So sodium is added. So remember, alcohols also produce effervescence with sodium metals. Alcohols tend to react. If I look at this chart over here, or alcohol ka reaction, so remember, alcohols, they do react with sodium metal and they do produce hydrogen gas when the reaction happens. So there's going to be effervescence and hydrogen gas is going to be produced. So remember this, carboxylic acid to acid hai hi hai, lekin alcohols, they also, unka jo end wala H hai na, the last H at the end, that's going to get removed and hydrogen gas is going to be produced in the reaction. So both of these options are going to be correct. Okay, the first thing is they're going to form esters with 1 and 2. And every time an ester is formed, whatever is produced, that will react with sodium metal. Is that clear?
Yes, sir.
So next is 37. In which reaction is the major product formed by nucleophilic substitution? So the first one is, this is a halogenoalkane and you're reacting it with potassium cyanide in ethanol. Okay, that's the first thing. So we have to look at nucleophilic substitution. So nucleophilic substitution happens over here. It happens with halogenoalkanes. You call it SN2 or SN1. There are 2 different mechanisms for that. So for primary, it's SN2 mechanism. For tertiary, it's SN1. So halogenoalkanes undergo nucleophilic substitution, and they do undergo nucleophilic substitution with the NaCN, ethanolic. That's the solvent. The CN -1 is the nucleophile. This is what happens in nucleophilic substitution. The mechanism is also written somewhere. So this is what happens in nucleophilic substitution. That you have a halogenoalkane. The bond is really polar. I'm describing the SN2 mechanism. So there's a very polar bond. Carbon is positive, Cl is partial negative. The OH -1 or any of the nucleophiles, CN -1 or NH3, The electrons are going to be attracted to this positive carbon atom. The electrons are going to go and bond with this positive carbon atom, and the Cl will get pushed away, knocked away, and it will eventually break off. So the OH will come in, or the NH3 or the Cn-1 will come in, and they will knock out the Cl and take its position. Okay, so that is nucleophilic substitution. So nucleophilic substitution will happen for halogenoalkanes. Halogenoalkanes are compounds that have halogens in them. So they have polarity in them. Anyways, the first one is correct. There's going to be nucleophilic substitution. A bromoethane, a halogenoalkane, reacts with potassium cyanide. Remember, KCN or NaCN is kind of the same thing. And the solvent is ethanol. The next one is you have a halogenoalkane and you're reacting it with ammonia in ethanol. So ethanolic ammonia under pressure. That will also produce, that will also lead to nucleophilic substitution. The NH3 ethanolic heating in a seal tube, that will result in the same thing. So that is also nucleophilic substitution. The last one, so the first two are nucleophilic substitution. The last one is not. You have a halogenoalkane. What happens is that if you react the halogenoalkane in NaOH ethanolic, and it's concentrated as well, so we can add that. So it's concentrated NaOH, but it's ethanolic. Then that would not lead to nucleophilic substitution. What that would lead to is elimination. It's going to turn into an alkene. What would happen is that you'll have a halogen with all its hydrogen atoms. And the H would be lost and the Cl would be lost and a double bond would be formed between them. That's an elimination reaction that's going to happen. So just remember that that is not going to be called nucleophilic. So that is not going to be called nucleophilic substitution. So, so the last one is not correct. Let's move to the next one. This is all about car engines. Which acids? Nitrogen dioxide is produced when petrol is burned in car engines. Which acids are made in the atmosphere as a result of nitrogen dioxide into the air? So all of them. Okay, acid rain is produced. What NO2 does is it reaches the atmosphere. The atmosphere already has other pollutants like SO2, and the NO2 will turn into NO and it will oxidize the SO2 into SO3. And so I think it's the first one is not going to be correct. I'll just explain this first. The NO gets converted into or reacts with oxygen and turns back into NO2. But anyways, what is acid rain? The SO3 reacts with water and turns into sulfuric acid. The NO2 reacts with water and turns either into nitric acid or nitrous acid or both. The only thing that it's not going to be produced, it's not going to be, that's not going to be produced, it's going to be sulfurous acid. Why sulfurous acid? Because uske andar NO2 ka koi kaam nahi. NO2 has nothing to do with it. Remember, NO2 does not make SO2. NO2 helps convert SO2 into SO3. So it's playing a part in making of sulfuric acid. But it's not playing a part in making of sulfurous acid. Sulfurous acid is SO2 reacting with water, turning into H2SO3. Now, for that, you don't need any help from nitrogen dioxide because SO2 was already made. So you don't need any help trying to make that, trying to convert it into sulfurous acid. Is this clear? This one?
Yes, sir.
So next is you've got a sample of X moles of Al2Cl6 are dissolved in water to give solution W. In order to precipitate all of the aluminium as its hydroxide, Y moles of sodium hydroxides are required. More of the alkali is added to redissolve the precipitate, giving solution Z. So which statements are correct? The initial pH of the solution W is below 7. So starting with the first thing, what happens when you dissolve Al2Cl6 in water? Now this is part of inorganic. Okay, so let me just quickly open the inorganic notes. Now this one. AlCl3, we have to look for AlCl3. Remember what happens with AlCl3, and I'll just give you a brief outline as well. Remember the hydrolysis of all these chlorides. You've got AlCl3, and AlCl3 mixes with water and forms aluminium hydroxide and produces HCl. This is what happens. There's a strong hydrolysis and a strongly acidic solution is produced. Now Al2Cl6 is something similar. It's two AlCl3 molecules datively bonded to each other. This is what it looks like. Like if you have one AlCl3 and you have another AlCl3, the lone pairs of one Cl, they datively get attracted to the aluminium of the other AlCl3, and the lone pairs of this Cl will get attracted to the aluminium atom over here. So there would be dative bonds that would be formed over here. So that's Al2Cl6, which is kind of the same as AlCl3. Now remember, there's going to be very strong hydrolysis that's going to happen, and AlCl3 is going to mix with water. Now this is the overall reaction that's going to happen. The reaction actually takes place in 2 steps. And the 2 steps are, let me go into a little detail. The 2 steps are that the first thing is that AlCl3 dissolves and dissociates and turns into Al3 plus aqueous. And you also have 3Cl minus 1 aqueous. And why is there a strong hydrolysis? The reason there's a strong hydrolysis is that aluminium has a very high positive charge. So what it does is it attracts the water molecules, which are very polar, but it attracts them very strongly. So oxygen has these lone pairs which have a slight negative charge. So it attracts these water molecules very, very strongly. And it attracts it so strongly that the positive H gets repelled because of the large positive charge over here, and the oxygen gets attracted very strongly to it. So eventually the water molecule dissociates. So, which is why aluminium hydroxide is produced. Aluminium ions are able to pull the OH ions because of the large positive charge, because of the very large positive charge on aluminium. They're able to attract the OH ions, which is why aluminium hydroxide is formed in the first place. But anyways, hydrolysis will happen and the H will get knocked out from water, and the H and the Cl will form HCl. So the first thing is the initial pH is going to be acidic. That is correct. Is this clear? This one? You clear? Yes or no?
Yes, sir.
So,
So it's going to be Al2Cl6 with water, and it's going to produce, overall, it's going to produce aluminium hydroxide, because the aluminium ions are going to dissociate and they will pull all the OH ions from water and they will attract those OH ions and bind with them, right? And the H will get knocked out and they're going to form HCl. So you need to balance this. There would be 2 aluminium hydroxides and there would be 6 HCls, and how many water molecules? I think there would be 6 water molecules, right? So there would be 6 water molecules that would be needed in the reaction. Anyways, which statement? Next one is Y is 3x. So he said that there were, what did he say? He said that there were X moles of Al2Cl6. And in order to precipitate all of the aluminium as its hydroxide, Y moles of sodium hydroxides are needed, are required. So so Y moles. So how many OH ions are needed for this? If you want to precipitate all of it, you need 6 of them, right? You need 6 OH ions. So for the reaction to happen more quickly, he wanted it to get precipitated quickly. So he added Y moles of sodium hydroxide. So that means you need, to form aluminium hydroxides, if you're adding NOH, you would need 6 OH ions. So 1 Al2Cl6 would require how many OH ions? It's going to require 6 OH ions. 6 OH ions would be needed. So if you're adding NaOH, then the OH ions will come from that. So so if there's X moles, what's the ratio? There's going to be 6 X moles of OH ions. So this one is going to be incorrect. That if there are X moles, then the moles of OH ions that would be needed would be 6X. Okay, remember, focus over here. You had Al2Cl6 and it was forming aluminium hydroxide, right? Now, if he was forming aluminium hydroxide, how many OH ions are needed? There are 6 OH ions needed. So one molecule needs 6 OH ions. Is this point clear? You clear? Yes or no?
Yes, sir.
Achha, so Rubab, is this clear? Alicia, is this clear?
Yes, sir.
Achha, so the ratio is one molecule needs 6. So if there are X moles of Al2Cl6, there would be 6X moles of OH ions needed. And all those OH ions, we're assuming, are coming from NaOH. So there would be 6. So the ratio would be 1:6, not 1:3. So the second statement is incorrect. And the next one is Z contains X moles of aluminium. What is Z? Z will not contain, I mean, you can have a look. Like one molecule contains how many aluminiums? 2, right? So one molecule contains 2 aluminiums, right? So whatever happens, one molecule contains 2 aluminiums. Like if you add one molecule of Al2Cl6 to anything, how many aluminium ions would be present? There would be 2 aluminium ions. Like over here, there are 2 aluminium ions. So the ratio is 1:2. So if there are X moles, then the moles of aluminium ions would be 2X. So it's going to be double the amount. It's going to be 2X. The amount of aluminiums is going to be twice that. So this one is also incorrect. So option 2 and 3 are both going to be incorrect because one molecule produces or has 2 aluminium ions. So if there are X moles, there would be 2X moles of aluminium ions. So is this clear?
Yes, sir.
So next one is you've got a species which can accept a lone pair of electrons to form a dative bond. So anything that has a completely empty orbital in its outer shell, that can accept a lone pair. So the first one is BF3. Boron has 5 electrons. So it's 1s2, 2s2, and or I can simply state that boron is in group 3. So boron has 3 electrons in its outer shell. So it's bonded to 3 fluorines. So it bonds with 1 fluorine, it gets an electron from 1 fluorine, it gets another electron from 1 fluorine. Its outer shell, second shell, is still not complete. It still needs 2 electrons. So if it needs 2 electrons, it's going to attract lone pairs. And it will form a dative bond from somewhere. So anything that has, and boron's electronic configuration outermost is this one. It's 2s1. It's got 3 electrons, 2px1, 2py1, and the 2pz is completely empty. So it gets electrons from fluorine, gets electrons from fluorine to fill this up, gets electrons from fluorine to fill this up. And it has this one orbital which is completely empty. And that needs to be filled up. So it can accept it can get a lone pair from somewhere. Same goes for H+1. H+1 has a completely empty shell. So it can attract electrons, 2 electrons from some other atom, right? So that can also form a dative bond. And the same goes for CH3+1. C has 4 electrons in its outer shell. Now, CH3, that means H gave electron to this one, H got, so 3 H's bonded. Carbon got electrons in all of them, and the last orbital is completely empty. CH3 needs 2 electrons. So it's going to be able to form a dative bond as well. So all 3 would be capable of forming dative bonds because they all need 2 electrons to complete the outer shell. H needs 2 electrons, B needs Boron needs 2 electrons to complete its outer shell. And carbon at the moment has 6 electrons. It also needs 2 electrons to complete its outer shell. As the next one is, many gases do not obey the general gas equation at high pressures. Why is this? So what's wrong with high pressures? What happens at higher pressures? Remember, gases, specifically the general gas equation is PV is equal to nRT, which is your ideal gas equation. What this equation states is that pressure is inversely proportional to, volume. So that means that if you keep on increasing pressure, the volume should keep on decreasing, right? And as pressure increases, volume must decrease, and the volume must go to 0. If pressure becomes infinite, if you go to really high pressure, the volume should come to 0. But the thing is, gases will not obey this at high pressures. Why would they not obey at high pressures? Because gases cannot be compressed indefinitely. Like you increase pressure, gas particles will come closer together, right? So the general gas equation assumes that most of the space is empty spaces, and the volume will decrease. This particular relationship will be followed. But the thing is, you keep on increasing pressure, and the volume will keep on decreasing. But the problem is that it's going to be compressible to a certain extent. At a certain point, if the pressure increases to a very high value, and you're continuously compressing it, what's going to happen is that the gas particles will become incompressible because they would be so tightly packed that there would be no more spaces left and it would be incompressible. So that's why the law, this particular law will not be followed at high pressure. Gases will become incompressible at high pressures. Remember that. Gases can only be compressed to a certain extent. This relationship, if you go to infinite pressure, the volume will not go to 0. It's not going to come to 0 because the compression can only happen to a certain extent. So at high pressure, the molecules have more energy. That's not true, because energy is a function of temperature, not of pressure. At high pressure, the volume of the molecule is larger proportion of the total volume. That's true because the empty spaces are gone. So if the empty spaces are gone, the gas will become kind of incompressible. At high pressure, the molecule experiences greater intermolecular forces as well. And that is also true. Remember, for ideal gases, the molecules, if they become close to each other, then they will stop behaving as a gas because the intermolecular forces would become really large, and they will start attracting each other, and they will liquefy. That's why molecules, they get liquefied at high pressures, because you bring them so close to each other that the forces of attraction would start, they'll start sticking to each other. They will turn into liquid, or they will either solidify. So at high pressures, the molecule experiences greater intermolecular force. That's also true. So only the first one is not true. So the reason the third one is true is that it will stop behaving as a gas altogether. So it will not obey the general gas equation. Is that clear as well? Okay.
Yes, sir.
Yes, sir.
So this is about Hess law. And remember, the Hess law is one path is equal to the other path, right? So the first one is, which expressions can be used to calculate the energy change delta Hz? So you're going from this point to this point, right? So this is your starting point, and that's where you end. So that's your start, that's your end. Hess law states you take another route, and the enthalpy change is going to be exactly the same. So that is what the Hess law is. So that's what the Hess law is. So what's the other route? Delta Hz. The other route is delta HF. So delta Hz is basically equal to delta HF CH4 and plus delta HC of CH4. So you go from this point to this point, that's delta HF CH4, enthalpy of formation of CH4, and this is enthalpy of combustion of CH4. Which expressions can be used to calculate the energy change delta Hc? So the first one is, I think, true. That's the one that we are getting. The first one is true. The second one is, he's talking about the enthalpy of combustion of carbon, which is probably not given over here. Okay, that's not given. And so that is definitely incorrect. And he's talking about the enthalpy of combustion of hydrogen as well. So let's have a look. I mean, that's got nothing to do with the cycle that I've made over here. So let's think on this, the second one. And this is the enthalpy change that we're trying to figure out. So ignore the other part. The first one is correct. We did that. So what is this equal to? What is happening here? Enthalpy of combustion of carbon. This is exactly what's happening. Carbon is turning into carbon dioxide. So it is the enthalpy of combustion of carbon, but not just the enthalpy of combustion of carbon. Carbon is turning into carbon dioxide, but it's also the enthalpy of combustion of hydrogen, because hydrogen is burning with oxygen to produce H2O. So it's enthalpy of combustion of hydrogen as well. And 2 times, because enthalpy of combustion of hydrogen is for 1 mole, you're burning 2 moles. So this particular path is the enthalpy of combustion of carbon plus the enthalpy of combustion of hydrogen as well. Is this clear? Is second wala clear?
Yes.
So then you've got the last one, option number 3, which is enthalpy of combustion of carbon monoxide and enthalpy of combustion of hydrogen. That's incorrect, because it's not the enthalpy of combustion of carbon monoxide, it's the enthalpy of combustion of carbon dioxide. Aapka jo carbon hai na, that's burning to produce carbon dioxide. So the third one is definitely incorrect. Okay. So the first 2 are correct. Uske baad ye agla kar lete hain ki which is this clear? Okay, one of the expression was you take this other path. Okay, that was one of the expressions. That was the Hess law. And that gave us enthalpy of formation of CH4 and enthalpy of combustion of CH4. The second one was true because usko humne literally interpret kiya कि this is the enthalpy of combustion of carbon dioxide, and it's also the enthalpy of combustion of hydrogen as well. The last one is incorrect. अच्छा ये बस जल्दी से कर लेते हैं कि you're given a sample of 17.15 moles of HI is in dynamic equilibrium with 2.27 moles of. So he's given you all the values. You just have to calculate the value of Kc, which is going to be, it's going to be HI concentration. He's asking for Kc, right? So it's going to be HI concentration squared. And the first one is true. Kc and Kp will not have any units. Why? Because you've got the same number of terms. Upar or niche, you have the exact same number of terms. So HI squared is going to be what? It's going to be 17.15 squared into 2.84. So try and calculate, do you get 4.45.6 or not? And the other one is that Kc and Kp will have different values, which is not true. The Kc and Kp values are going to be exactly the same. Remember this, when it doesn't have any units, so you can directly use moles. Either you're calculating Kc or Kp. I mean, you don't need to calculate concentration. Why? Because divide by volume, divide by volume, divide by volume. All the moles, the volume terms will get cancelled out. The other thing is, for partial pressure, you have to find the partial pressure. You have to find the mole fraction multiplied by the pressure, but multiplied by the pressure wala jo part hai na, that will also get cancelled out, because if the numerator and denominator terms are equal, then they're going to get cancelled out. So remember this, okay, if there are no units, the numerator terms and the denominator terms are equal, then that means you can just calculate Kc and Kp by using moles directly. No need to find partial pressure, no need to find concentration. Is this clear?
Yes.
Yes, sir.
Chalo, theek hai. Let's continue with this, theek hai? Let's continue tomorrow then, theek hai? Chale, okay, everyone.
Allah Hafiz.
Hafiz.